Today, we're diving into a research paper that could totally shake up how AI talks to data. We're moving way beyond simple chat and into a deep, structured dialogue with databases.
All right, let's get into it. Here's what we're going to cover. First, we'll unpack the big communication problem between AI and databases. Then, we'll look at a really clever new solution called function calling. After that, we'll see how the researchers built a custom test to push these AIs to their limits, check out the leaderboard to see who won, and finally, talk about what this all means for the future.
So first things first, let's set the stage. The core challenge here is that large language models and databases, well, they speak completely different languages, and that creates a huge communication barrier. You see, on one hand, you've got LLMs, which are masters of human conversation, all its nuance and messiness. And on the other hand, you have databases, which need perfectly structured, super rigid commands in languages like SQL. For years, the main way to solve this translation problem has been a method called text to SQL. This slide right here shows that old way perfectly. You ask a normal question, and the AI tries its best to spit out a perfect SQL query. But, as the researchers point out, different databases have their own unique SQL dialects. This makes the whole text-to-SQL thing pretty brittle and just not very flexible.
So, this paper suggests a totally different way of thinking about this. Instead of translating language into code, what if we gave the AI a tool belt, a set of specific actions it already knows how to perform? This approach is called function calling. Basically, instead of trying to teach the AI every single dialect of SQL out there, we just give it one universal tool, maybe called query database. The AI's job isn't to write the code from scratch. Its job is to figure out what you want and then just fill out a form, a JSON object, with the right parameters. It's way more efficient.
And this is a brilliant example of how it works. The question, how many menu items are priced under $20, doesn't get turned into some complicated SQL string. Nope. The model just figures out, okay, I need the menus collection, and then it builds a simple filter. Find the price that's less than 20. It's clean, it's simple, it's universal.
And here's where it gets really powerful: scalability. That exact same tool can handle way more complex questions just by adding more arguments. A simple filter can get an aggregation like count added on, and a really complex one can add a search, another filter, and a grouping operation. It's one tool for the whole shebang.
Okay, so if you're going to test a totally new method, a standard off-the-shelf test just isn't going to cut it. The researchers had to build their own custom gauntlet, a benchmark they called DBGorilla, designed specifically to push this function calling approach to its absolute limit.
Building this thing was a really clever three-stage process. First, they had an LLM create 5 realistic but fake database setups to have a controlled testing ground. Then, using a technique called self-instruct, they generated 315 test questions to cover all the bases. And finally, they used another AI process called reflection, where a second AI acts like a critic, reviewing and improving the questions to make sure they were tough but fair.
And here is a peek at what one of those synthetic databases actually looked like. This is the restaurant one. You can see how there are different but related collections: restaurants, menus, reservations. And they all have different kinds of properties like text, numbers, and true-false values. This whole structure was designed to be a really tough workout for the AI.
So we have our new method, function calling, and we have our custom-built gauntlet, DBGorilla. It's time for the main event, seeing which of today's top AI models could actually pull this off.
This is the big question, right? When you put all the major players from OpenAI, Anthropic, Google, and the others up against this super specific, really hard test, who comes out on top?
And here are the results. This is the official DBGorilla leaderboard. You can see right away that a clear hierarchy forms. There's a top tier with 4 models: Claude 3.5 Sonnet, GPT-4o Mini, GPT-4o, and Gemini 1.5 Pro that are just way ahead of everyone else.
Taking the top spot was Anthropic's Claude 3.5 Sonnet. It hit a 74.3% exact match score. Now, what that means is it generated the perfectly correct JSON for the function call almost 3 out of every 4 times. That's incredibly impressive.
But check this out, because this next number might be even more telling. Even when the models weren't a perfect match, their performance was still amazing. This is measured by something called an abstract syntax tree, or AST score.
A score of 0.973 means it almost always understood the logic of the request. It knew what to filter, what to group, what to count, even if it got a tiny detail wrong. It's a measure of understanding the structure.
But you know, the final score never tells the whole story. To really get what's going on, we need to dig a little deeper and see where these models were great and, maybe more importantly, where they stumbled. These radar plots are an awesome way to see that breakdown. Just think of it like this. The wider and fuller the shape, the better the model performed on that specific task. For the top models, you can see they're strong pretty much all around, but there are a few noticeable dips.
And when you look closely at the data, a really fascinating weakness shows up. All the top models were fantastic with simple true-false filters like is vegetarian equals true. But they struggled to tell the difference between a broad search query, like finding menu items related to pasta, and a super-specific text property filter for an exact match, like finding the item named exactly spaghetti carbonara. That's a subtle difference, but it's absolutely critical for getting the right answer.
The researchers didn't stop there, though. They ran what are called ablation studies, which is basically where you start taking pieces away from the experiment to see what actually makes a difference. For example, they tested if forcing the AI to explain its reasoning, to provide a rationale, would make it more accurate.
And the results were, well, kind of surprising. For a top-tier model like GPT-4o, things like adding a rationale, letting it run multiple queries at once, or even changing the tool structure, none of it really had any impact on the final accuracy. The core ability is just that solid.
All right, so let's zoom out and think about the big picture. What does all this research really mean for the future of how we deal with information?
The main takeaway here is that function calling is a seriously effective and flexible way to finally bridge that gap between normal human language and structured databases. We're moving away from those fragile old text-to-SQL systems and into a future where we can have a much more natural conversation with our data.
And that leaves us with one final big question to think about. If AI gets so good at understanding what we mean that it can just use its tools to get us the exact information we want, will anyone ever need to learn a query language like SQL again? Or are we heading for a future where we all just talk to our data?